I'm Mike Birch, I'm the Systems Manager for Offshore Power at Baker Hughes. I've been with Baker for 13 years. Primary focus is high voltage AC connection systems. We have an existing product range that we developed in the late 90s, primarily focused on subsea processing applications, so delivering high voltage power from shore out to subsea pumps and compressors. So it's really leveraging on that knowledge now for floating wind, even for power from shore for decarbonisation applications. So we were the first company in the world to deliver high voltage AC connectors for subsea use. So our first wet connect was a 12 kilovolt 400 amp wet mate connector, and we also delivered a 12 kV 400 amp dry mate connector, or series of connectors to connect a transformer. So we are the industry leader on the dry mate side. We have some quite unique technologies on our wet connect that no one else has. We have a 3-phase wet connector, which means the 3 pins are all contained within one housing, whereas others in the industry use single-phase connectors, which basically means you need 3 connections for every cable, 3 potential leak paths. In the world today, we've got around 30 floating wind turbines. There's one in the Norwegian sector, which is used for oil and gas decarbonisation. That's 11 floating wind turbines. There's 5 as a demonstrator of Scotland as part of the Highwind Scotland project. And then there's other 1s and 2s dotted around the world, so they're really in small numbers and really just pilots today. When we look at large-scale floating wind farms, how do you interconnect all these turbines and bring system availability, knowing that we'll definitely have failures on the cables which connect the turbines. They are very difficult for the companies to ensure, because if you lose the cable, you lose the train of power. By 2050, there will be some 270 gigawatts of floating wind power. Governments have made commitments to reducing emissions, therefore they're moving to green energy. So this growth in offshore floating wind will be exponential. It's not there today, it's coming by the end of the decade. What does 270 gigawatts of floating wind power look like by 2050? It's about 700 turbines per year for the next 25 years need to be deployed. We haven't delivered this system, but it is the same technology as we've delivered previously for subsea processing applications. Then we have leveraged that technology, and through qualification and development, we've stepped that up to 36 kV 500 amps, and we're currently working on the 66 kV 1000 amp connector. It hasn't been deployed yet. Qualification will be finished in 2025, which is in time for the floating wind market growth in 2027. What's important for floating wind, unlike the oil and gas industry, is we cannot have bespoke systems. The margins are so low on the renewables side, we have to have cookie cutter. We have to have structured product, structured building blocks, so that it's the same in every wind farm. There's definitely going to be cable differences. The connectors are the same, the subsea structure is the same, the turbines become the same. That's the only way you get economies of scale and you bring down that levelised cost of energy. Within that discussion, Baker Hughes have a natural place. With our experience and 30, 40 years of subsea engineering, given our high voltage power background, we're perfectly placed to support that discussions within the industry.